Good morning, Geometry Initiative iPad students. This is Mr. Lane coming at you with section 5.3 over medians and altitudes of triangles. As always, pay attention for the secret word, read the objective, read the why, and answer number 5. You might have to do this one in an Edge Creations and send it to me. So I hope you're having a good morning. Let's get to rocking and rolling. We've got the median of a triangle, just a quick definition of it. It's going to be a segment whose endpoints are the vertex of the triangle and the midpoint of the opposite side. So anyways, we're going to start at a vertex. We're going to go to the midpoint of the opposite side, cutting that opposite side into two congruent parts. Now, how many medians would there be in a triangle? Well, there's 3 vertices and 3 opposite sides, so there must be 3 different medians of a triangle. When they all are drawn into the triangle, they will always connect, and we call that the centroid. So that's the point of currency of all the medians of the triangle. What's important about the centroid is if we're going to balance, like if we had some sort of paper triangle and we're going to balance that on a pencil, then if we could find the centroid, we could put it on the pencil and balance it. It'd be a fun little activity if you want to try and do that actually. And I'm sure you, at this point, if you're already watching this video, you're probably a little bit ahead of the game, so feel free to do that. Let's see, the centroid theorem says that the centroid is the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So in other words, if we just look at one of these, here, let me get a little highlighter on here. If we just look at one of these medians, then from P to C is 2/3, where from X to P is 1/3 the length of that segment. And that's what we know from this theorem. Okay, so I'm sure there'll be some problems come up about that in probably this example right here. So let's see, in a triangle, or in triangle LMN, LR is 21 and SQ is 4. Find the length of each. We're supposed to find LS, so that's this one right here. And we're supposed to find, let's see, NQ, full distance right there. Okay, alright. Well, from looking at the triangle, we have the distance RL as 21, so we know that LS would be 2/3 of that distance. So I think all we have to do is multiply 21 times 2/3, and that's going to equal, looks like 14. So this distance here would be 14 for LS. And NQ, well, 4 is 2/3, so I need 2 more 4s to make it across here. So another 4 plus 4 should be 8 for this distance, which is 2/3 of the way all the way across. So I think we'd need 2 more 4s, creating 8 for this length. Alright, let's move on. Regular geometry students, bada boom, bada bang. Right there, let's keep rocking and rolling. Let's see, a sculptor is shaping a triangular piece of iron that will balance on a point on a cone. Now, what is the coordinates, or at what coordinates will the triangular region balance? So let's see, let's connect some dots here real quick. Okay, so we want to find the centroid basically. So we want to start from the vertex and go to the midpoint of the opposite side. So notice that I go over 1 and down 2, over 1 and down 2. So this must be the midpoint right here. So I could go ahead and draw that one in. Okay. Now let's see. Here I go up 1 over 1, 2, 3, 4. So half of that would be up a half and over 2. So here's your midpoint right here. And we're going to go across And really, we know that they're all three going to intersect at the same location, so I can take a little shortcut and say this must be my centroid right here. So all I have to do is figure out the location of that, which would be 8 up 1, 2, 3, 4, 5. So 8, 5 would be the location that would balance if I stuck a point right there on that triangle. I could balance it on a pencil top or whatever I wanted to balance it on. Okay, click that. Now we're rock and roll. Alright, the altitude of a triangle is a perpendicular segment from a vertex to a line containing the opposite side. The orthocenter of a triangle is the point of concurrency for the altitude of a triangle. Let's talk about a right triangle real quick here. Okay, so we're going to have three altitudes in a right triangle. If I start from this vertex and do the perpendicular segment, it's actually going to give me that right angle right there. So this is an altitude, with this being our base. Same thing with this one. If I was to draw the vertices straight perpendicular to this right angle, then this would be an altitude, and we could use this as a base. Well, from this vertice, then the altitude is going to form the 90-degree angle with that third side, so the altitude would be somewhere around there. Notice that they meet right here for all the altitudes off in that corner. That's the orthocenter, the point of concurrency of all the altitudes. Find the orthocenter of the triangle with the vertices. Let's see, 3, -2, 1, 2, 3, 6. And let's see, 1, 2, 3, 4, 5, 6, 7, 1. Okay. Okay, I'm going to count the slope real quick because we might get lucky here. 1, 2, 3, 1, 2, 3, 4. So that would be what? Up 3 over 4. Okay, I'm going to count this one real quick. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. No, we didn't get lucky. Okay. And then okay, I'm going to do the easy one real quick. So from this vertex we got to form a 90-degree angle. So if we just drop this straight down, and right there would be our altitude for that one. So I just need to intersect with that one more time, and we'll actually have this problem worked out. So what I need to do then is, if I choose this vertex, I need to go perpendicular to this slope, which would be a positive 4/5. So from right here, I'm going to count up 4 and over 5, and then I'll be able to draw in that altitude. So let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5. And let's draw that in real quick. So it looks like our altitudes are going to meet right about here, which is close to that point 7, 1. Alright. Looks like that's going to wrap us up this morning. This is Mr. Lane signing off from OHS High School. Have a great day.